Hello, my name is Philip and welcome to Chemistry Class Notes. So today, without wasting much time, we're going to be looking at molecular formula, empirical formula, and vapor density calculations involving these three terms. So before we start, we know that molecular formula is actually the actual formula of a compound, while empirical formula is the simplest formula of a compound. So these are past jamb questions, although this video will also be of benefit for people writing waec, neco and the likes. So without wasting much time, let's look at this first question. It said a compound contains 40% of carbon, 6.7 hydrogen and 53.3% oxygen. If the molar mass of the compound is 180, find the molecular formula. So these are your options. So in solving this, just have to do something like this. It's between carbon, hydrogen and oxygen. So the percentage for carbon we're told is 40. That of hydrogen is 6.7 and oxygen is 53.3. So what the first thing you do, you have to divide by their atomic masses. From here you are given carbon is 12, hydrogen is 1, then hydrogen is 1, oxygen is 16. So when you divide, you're going to get 3.33 here. Then here, of course, you're still getting 6.7. Then here you are getting also 3.33. So when you got to this stage, we have to get whole number. So what you have to do is divide by the smallest. So over 3.33 over 3.33 over 3.33. So when you do that, this is 1, this is 1, and here you're getting 2. So from here, you can now write it that the empirical formula, what you get here now is the empirical formula, which is CH2O. This is the empirical formula, but we're told to calculate molecular formula, right? So remember, C, we don't have to put 1. O, we don't have to put 1. We just say CH2O. So in order to get the molecular formula, you use this format. CH2O N equals to the molar mass is 180. 180. I just want to maximize the space. So what you do here, we already know that C is 12, H is 1, O is 16. So I'll put those values inside here. I'll get something like this. That's 12 plus 2 times 1 is 2 plus 16. So I'll say N equals to 180. Don't mind my space, just want to manage it. So from here, you add everything inside here, you're getting that is 30. 30N equals to 180. N is 180 over 30. When you do that, you get 6. So the next step now is, since N is 6, I have to put this N, which is 6, in place of, I have to put it N here. So I'm going to put 6 here and open the bracket. When I do that, I'm going to get something like this. That is 6 times C, that's CC, 6 times 2, H2, then times O, O6. So this is the molecular formula. Why this first one calculated here is the empirical formula. Remember, empirical formula is the simplest formula of a compound, which relates the ratio of each kind of atom as in a compound, where molecular formula is the actual formula of a compound. So your answer here will be C. Sorry, this 12. This 12. So your answer is C. Number 2. An oxide SO2 has a vapor density of 32. What is the atomic mass of S? First of all, you know that molecular mass equals to 2 times vapor density. So they are saying that this compound now, it has a vapor density of 32. What is the atomic mass of X? So we're going to equate this compound to this molecular mass. Let me use this one. That is 2 times vapor density is 32. That is 64. But actually it's the molecular mass of this compound we're looking at. So we're going to equate this SO2 to 64. SO2 equals to 64. Then S plus O2 equals to 64. O is 16. 16 times 2, 32. S plus 32 equals to 64. So you will make S the center of the formula. S equals to 64 minus 32. So now we are getting 32. So your answer is B. Material. Let me just do something like this. Okay. So the material, a gaseous metallic chloride MCl3 consists of 20.22% of M by mass. The formula of chlorine is, we use something like this, and this involving two compounds, two elements, but they are giving you the percentage of one as 20.22%. That means that the rest is the percentage for the others. So in order to get the percentage of chlorine, what you need to do is subtract 20.22 from 100. That's how you get the percentage of chlorine, even though they didn't give you. So the first thing I have to do, we know that the M, metallic M, is 20.22%, but for chlorine, you subtract it from 100 to get the percentage of chlorine. I'll just say 100 minus 20.22, that's percent. So you are getting 79.78%. That is for Cl. So it's between M and Cl. M is 20.22. While Cl is 79.78. As usual, you have to divide by the atomic masses. So M was 27. Cl 35.5. So when you divide, you are getting 0.748 here. Then here you are getting 2.247. So you want to make it whole number. So you divide by the smallest. So the smallest value here is 0.748. Divide both sides by 0.748. Of course, this one you get 1. Then when you divide this one, you're getting 3. So the formula will be MCl3. Remember, no need to put M1. No need. MCl3. So the answer is C. 4. The certain hydrocarbon on complete combustion at STP produce 89.6 gram TM cube of CO2 and 54 gram of HO. The hydrogen should be sorry, there's a mistake here. This should be hydrocarbon. Yeah, the hydrocarbon should be, this should be hydrocarbon. Alright, but let's look at the question. We are giving this value for CO2 and 54 gram of H2. Remember, we are interested in getting the carbon and hydrogen. But here in this case of combustion, we're giving CO2 and H2O. So we're going to get carbon from this CO2. I'm going to get hydrogen from this H2O. So the first thing we're going to do is that since for CO2 we're giving 89.6 gram dm cube. Remember at STP, molar volume of gas, the constant there is 22.4. So we have amount in mole equals to the volume of gas over 22.4 dm cube. Of course, this is a constant value. Any gas at STP, 20.4 dm cube. So yeah, we just calculate, and we also know that amount in mole is equals to mass over molar mass. So I'll just say, since N equals to M over MM, and N is also equals to volume of gas over 22.4, so I can say that mass over molar mass is equal to the volume of gas over 22.4. So what I will just do, I'll put this volume here. I'll put this volume here. I want to find the mass of this gas. I want to find the mass so that I can find I convert to mole back. And the molar mass, we know this molar mass, CO2. C is 12, O is 16, everything will be 44. So I'll just put the values. So M equals to volume of gas is 89.6 over 22.4 over this. The molar mass for CO2 is 44. So when you cross multiply, M will now be equal to 176 gram. When you cross multiply, this is what you get at the end of the day. So since I've gotten this one, this is the mass of the gas. So I want to now calculate the amount in mole of this gas. And amount in mole equals to mass over molar mass. So I'm getting 4 mole. Since 1 mole of CO2 is equal to this 4, that means 1 mole of carbon will also be equal to 4. Since 1 mole of CO2 is 4, from what you have calculated here, meaning 1 mole of carbon will also be equal to 4. So calculate the mole for carbon from this CO2. We're going to do the same for hydrogen in H2O. For water now, I'll calculate the amount in mole of this water. Mass 54 over molar mass of H2O. H2O, the molar mass, O is 16, H is 1, 2 times 1, 2, everything is 18. So N will now be equals to, when you divide it, you are getting 3. Of course, since 1 mole of H2O is 3, then 1 mole of hydrogen will be equals to 2 times 3 will be equals to 6 mole. So for carbon we got 4, while for hydrogen we're getting 6. That's C for H6. The reason I multiply by 2 is because of this 2. The 2 in H2. Hydrogen is diatomic here. If it was H3O, it would have been times 3. If it was just H, that means I don't have to multiply. Because of this 2 here, that's why I multiply by 2. That's why it's 6 more. So it's now 6 for H6. Hydrocarbon has a chemical formula CH and a vapor density of 39. Determine its molecular formula, just like the others. Because molecular mass equals to 2 times vapor density. Vapor density is 39. That's 2 times 39. So you are getting 78. So you are equating this is the empirical formula CHN will be equal to 78, which is the molar mass. So what you have to do, we know C, we know H. C is 12, H is 1. So that's 13, N equals to 78. 78 over 13. When you divide 78 by 13, when you divide 78 by 13, you get 6. So at the end of the day, this value, put it here and open the bracket. That's C6 H6. This 6, I put it here, put in bracket. It will times each of them inside. That's how I get C6 H6. So the answer is D. If the molar mass of tetrahydrocyclic acid is 98, calculate its vapor density. As usual, molar mass is equals to 2 times vapor density. And they've told you that the molar mass of this is 98. The molar mass is 98, so I'll say 98 equals to 2 times vapor density. I'll just divide both sides by 2. So vapor density is equals to 98 divided by 2. That is 49. So the answer is B. 1 mole of hydrocarbon contains 6 grams of hydrogen. If the molecular weight is 54, the hydrocarbon is an dash. Alkene. This should be alkane. I think one of the options will be alkane. Okay, 1 mole of hydrocarbon contains 6 grams of hydrogen. If the molecular weight is 54, okay, the hydrocarbon is CH, right? Let me use this one. The molecular weight is 64, but we only know one of the hydrocarbon. CH is equals to 54. It's like saying C plus H equals to 54. So we know that it contains 6 grams of hydrogen. They didn't give us the one for carbon. So that's C plus 6 equals to 54. C equals to 54 minus 6. That's C equals to 58. 58. So the mass of carbon is 58 and that of hydrogen is 6 from the question. So I'm going to C and H. I'm going to put 58 here. Sorry, this is 48. I'm going to put 48 here and 6 here from here. Of course, divided by their atomic mass. So when you do that, you are getting 4 here, you get 6 here. So that's C4H6. So this C4H6 is that's so this is C4H6. This is an alkyne. Triple double bond is alkyne. So the name is butyne, right? Butyne is under naming of organic compounds. If I see your response, I might want to do a video on naming organic compounds. Just know this is butyne. It is an alkyne because it has 3 double bonds. So your answer to this question is that it is an alkyne. Why? Because of this 3 double bond from C4H6. You can count it. There are 3 hydrogen here, 3 hydrogen here, that's 6. Then 4 carbon. 25 cm cube of 0.02 mole plasma hydroxide neutralize 0.03 gram of monobasic organic acid. Having the general formula CnH2n plus 1 COH. The molecular formula of the acid is dash. So for this question, we have to take it step by step. Because first we have to calculate from this question you are giving, you have to calculate the molecular mass so that you can calculate this value. Then before you now use it to solve. So I want to calculate the molecular mass now. We are giving this. I want to calculate the molecular mass. And we know that concentration gram dm cube is equals to mass over volume times 1000 dm cube. So the mass is 0.03, the volume is 25 times 1000. That's 0.03 over 25 times 1000. When you do that, you are getting 1.2 gram dm cube. Then you now use the second formula, which is concentration in gram per dm cube equals to concentration in mole per dm cube times molar mass. From here I will make molar mass instead of formulas because I'm looking for molar mass. That's how I have to use this formula. Different people might have different ways of solving it. What's important is that you understand the pattern and you get the right answer. So I'm going to make molar mass instead of formula. It should not be molar mass equals to this concentration gram dm cube over concentration mole dm cube. The concentration in gram per dm cube is when you calculated, while the the concentration in mole per dm cube, or you call it molar concentration, is one in your question. So I just put the two values. That is molar mass equals to 1.2 over 0.02. You are getting 60. So I'm going to equate this general formula will be equal to this molar mass so that I can find n. I want to find n so that I can use it to complete my calculation. So CnH2n plus 1 COOH equals to 60. So from here, I want to find n. I'll just put the values for C, H, C, O, O, H. You know, C is 12, H is 1, O is 16. So it will be, of course, 12 times n. This is 12n plus 2 times n. 2 times n, 2n. Then H times 2, that's 1. 1 times 2n. This 2n plus 1 plus C is 12 plus O 16 plus 16 plus H. Everything is equal to 60. When you 12n plus 12n, that's 14n. 1 plus 12 plus 16 plus 16 and plus 1, you get 46 equals to 60. N equals to 60 minus 46. You will now get, that is 14n, sorry. 14n equals to 60 minus 46. So I said 40n equals to 60 minus 46. That's 14n equals to 14. N equals to 14 over 14, which equals to 1. So I want to now put this n equals to 1 into this formula so that I can get the name, the name of the compound. So if I put 1 in place of this n, it will be, I don't have to put C1, I just C plus 2 times 1, 2 plus this one, that's 3, H3, COOH. This is the answer. So this compound is ethanoic acid. It is 2. Methanoic, that's 1. Then propanoic, that's 3. Then butanoic is 5. So these are, organic chemistry, organic compounds. Naming of compounds is a separate topic on its own. Alright, so the answer is C, which is ethanoic acid. Example of a substance containing only carbon and hydrogen burned in excess oxygen to yield 4.4 grams of CO2 and 2.7 grams of H2O. The chemical formula of the substance is, we are given this combustion, we are given 4.4 grams of CO2, 2.7 grams of H2O, just like the previous question, and the fourth or fifth question. So we are going to look for the, first of all, we calculate the amount in mole of CO2. Then from there we can calculate the amount in mole of carbon. The same thing here, we calculate the amount in mole of H2O with this gram. Then from there we can calculate the one for hydrogen, because we're interested in carbon and hydrogen. So for carbon, for this carbon now, first of all, get the amount in mole of this CO2, which is 4.4 gram. Okay, 4.4 over CO2. C is 12, O is 16. When you 2 times 16 plus 12, you get 44. So n equals to, when you divide it, you are getting 0.1. Like the other question, since 1 mole of CO2 equals to 0.1, what you calculated, that means 1 mole of carbon will also be equal to 0.1. So you calculated C for carbon. Let's do the one for hydrogen from water. So I'm going to do the same thing. Mass 2.7, molar mass. O is 16, H is 1, plus this times this 2, that's 16 plus 2, 18. So you get, when you divide 0.15. So since 1 mole of H2O is equals to 0.15, that means 1 mole of hydrogen will be equals to 2 times 0.15. Because of these two, hydrogen is the atomic, that's why. So you are getting 0.3. So C from here is 0.1, H 0.3. As usual, you divide by the smallest. We want it in whole number. 0.1, 0.1. So this, you get 1, you get 3. That's CH3. Your answer should be A. Last question. 1 mole of hydrocarbon contains 40 grams of carbon. If its variable density is 28, the hydrocarbon is, as usual, molecular mass equals to 2 times vapor density. Vapor density is 28, so 2 times 28, you get 56. So hydrocarbon, 1 mole of hydrocarbon, now, CH, so is equal to okay, this CH now is equal to the molar mass, which is 56 we just calculated. So we're given, the carbon contains 48. We're not given that for hydrogen. That's C plus H equals to 56. 48 plus C plus H equals to 56. That is, H should now be equals to 56 minus 48. H is 8. So you have C and H. C is 48. H is 8. Because divided by the atomic masses. C is 12, H is 1. When you do that, you get 4 here, 8 here. That is C for H8. So you have to draw the structure to know whether it to be an alkane, or can be aromatic. So you say C for H8 is this. I want to draw the structure here. So 1, 2, 3, 4. So this is C for H8. 1, 2, 3, 4. Count the hydrogen. 1, 2, 3, 4, 5, 6, 7, 8. So C for H8. This is an alkene. It has double bond. Alkyne has triple bond. Then alkane, single bond. Right? So this is protein, but they're not asking for the name. They're just asking you of the the general, family name, which is an akin because of this double bond. Remember, it's gotten from this formula C4H8. That's how I used to draw the structure. So your answer is B, akin. So that's the end of the video. So this video is just people writing. These are part jamb questions, but it's going to be of benefit for those that want to write maybe waec and neco. So once again, if you enjoyed the video, you can leave a like and subscribe. And if you feel you want to encourage me, I will leave my account details in the description below. Thanks.